Good morning, happy Monday. And we are continuing today in our series on author perspectives. Now, these books aren't just any old books. They may appear as first, as they are just informational texts, but by giving you the information in the book, these series of texts are intended from the author's perspective to push you in a certain direction, to make you feel a certain type of way, and to create a sense that you need to do something, and you need to do something differently for mostly the sake of our planet. So today's read aloud is, What's So Bad About Gasoline? Yeah. Now, a couple of things for you to keep in mind while we read this book and thinking about your response questions afterward. You think about, what is the author's purpose in writing this book? And how do the illustrations and graphics help you understand what's going on in the book? And then finally, does the information in this book make you change or want to change your behaviors or feelings around gasoline? All right, let's get to it. What's so bad about gasoline? Here we are. Fossil Fuels and What They Do by Anne Rockwell, illustrated by Paul Mesel. Yes. A common sight, particularly on the Golden Gate Bridge and other bridges in the Bay Area here. What's so bad about gasoline? We go to the gas station and fill up the tanks of our cars, and we're ready to go anywhere, everywhere. In big cars, small cars, any kinds of cars. Gasoline is what makes cars go. What is gasoline anyway? Gasoline is a kind of fuel. When it's burned, it gives engines power. But carbon dioxide, other gases, and small particles of ash go into the atmosphere as the fuel burns. These are called emissions. Carbon dioxide is a gas that traps heat above the Earth's atmosphere. Too much carbon dioxide in the atmosphere makes the Earth warmer than it should be. We call this global warming. We're all familiar with that term. So we see here the sun, see a layer of carbon dioxide released into the atmosphere creates a greenhouse effect. What they mean by a greenhouse effect, if you've ever seen a greenhouse in real life, it's a place where there is a glass artificial shell over plants, and that helps trap in heat because some of the sun's rays come in the greenhouse and not all of them bounce off and leave. Some are trapped. Now, carbon dioxide does this same thing in our atmosphere. It makes it so the sun's rays go ding, and some of them bounce off, but ooh, they're reflected back by the greenhouse layer of carbon dioxide. Every year, more and more people all over the world drive cars, and every year the Earth grows warmer. Gasoline is made from petroleum, which is a fossil fuel. Fossils are what remain of plants and animals that lived millions or billions of years ago. Maybe you've seen some in stone. You can't see the ones that make petroleum, for they are too tiny, but they are there. Long ago, tiny plants and animals lived in oceans that covered much of the Earth. When these plants and animals died, they drifted down to the ocean floor. As millions of years passed, they became covered with sand. As more time passed, the sand turned back to rock. The decaying matter from the tiny plants and animals was trapped beneath the rock. This trapped decaying matter changed into petroleum. Some of the oceans dried up and left huge petroleum deposits deep underground. Some petroleum regained or remained under the water of the ocean. These deposits under land or sea are where we get petroleum or crude oil to make gasoline. That's on the water? Yep, it's as big as a city block. How do these little illustrations help you to understand the story? Does this little dialogue here put things in better terms for you to understand? A useful trick by the author and illustrator. People knew about petroleum long ago. There is more in the Middle East than anywhere else in the world. In the sandy deserts of these lands, people sometimes found sand that was moist and oily. Petroleum had seeped up through the ground. They used this oily material to waterproof boats, to preserve mummies, or to rub on their dry skin. They never tried to dig up more because they didn't need to. They didn't use much. Petroleum is still used today to make skin lotions. How about that? Bitumen is thickened petroleum that is still used in road paving. Ancient builders used it to strengthen bricks in the mortar that held bricks and stones together. 2,000 years ago, Arabians took baths in petroleum oil and water that they thought strengthened their bodies. The first oil wells were drilled in China during the 4th century. Wells dug with a bamboo pole could reach depths of 800 feet. Can you imagine that? Pushing down with a bamboo pole. 800 feet. The drilling process was discovered in the 8th century. Distilling changes a chemical substance into something else. When a liquid chemical substance is heated to the boiling point, a new kind of liquid is given off. This is called a distillate. In the 19th century, people discovered that they could make kerosene out of distilled petroleum. Kerosene was a very useful distillate. People lit lamps with it and burned it in their stoves to keep warm. But they still didn't use much petroleum. They didn't use much still. Everything changed when the automobile was invented in the late 19th century. Then petroleum became very useful. It could be distilled into gasoline, which made cars go far and fast. It worked better in car engines than kerosene did. Gasoline was cheap, and there seemed to be plenty of the crude oil needed to make it if people dug deep enough in the right places. Interesting. Notice the author using words like, there seemed to be plenty. People began digging and digging deeper and deeper to find deposits of petroleum. They learned how to put floating oil rigs out on the ocean to drill holes and pump it from under the sea floor. As people dug and pumped more and more crude oil, they made more and more gasoline in oil refineries. Refineries are where crude oil is distilled into gasoline. Gasoline became plentiful, making it possible for more and more people to drive their own cars, not to mention tractors, lawnmowers, motorboats, and other gas-powered vehicles to make life easier or even more fun. Another kind of fossil fuel is coal. Coal is not a liquid fuel like petroleum, but solid like a rock. It is not made from microscopic plants and animals. Instead, it is made from plants that once grew in huge swamps that covered the earth. We dig it out of the earth in coal mines and burn it to heat homes and make machines work. Some of these machines make the electricity we use. Some help people make things in factories. But burning coal also puts a lot of carbon dioxide and other emissions into the atmosphere. There is a bad thing about this. Fossil fuels such as gasoline and coal emit more carbon dioxide than any other kind of fuel. They make so much carbon dioxide because they are made of carbon. Carbon is part of every living thing. We are made of carbon. So are the plants that grow in our yards and the birds and insects that live in them. When you burn carbon, it burns long and hot. But because it is made from living things, or organic matter, not all of it burns. Partially burned carbon pollutes the air we breathe. It makes it dirty, and every year the people of the world burn more fossil fuel. More and more carbon dioxide traps more and more heat above the Earth's atmosphere. Scientists who study the Earth and the environment now think the warmer air makes glaciers and polar ice caps melt. Sea levels rise, shorelines and islands shrink. Many plants and animal species cannot live in the places that they always have. The world is changing, and the changes aren't good. Captain, that glacier is much smaller this year. Wow, that house is falling into the ocean. Mhm. One day, there won't be any more petroleum. It's what we call a finite resource. There's only a certain amount of it on this planet. It will be all used up. When it's gone, we won't be able to make any more because it was made by nature billions of years ago. It took a long time for prehistoric plants and animals that died to turn into coal and petroleum. If people keep using these fuels, a lot more damage will be done to all living things on the earth. For nothing does more damage to the atmosphere than burning fossil fuels. We need to find other ways to get the fuel we need. We have to find ways to use less too. And we need to find these things soon. Fortunately, there are other ways, if we're smart enough to think of them and willing to change our habits. We can harness and store power from the sun to make machines go. We can use windmills and harness and store power from wind. We can use nuclear energy. We can capture and store energy from waves and tides in the ocean. We can even capture emissions from factory chimneys and recycle them. That way they don't go up into the atmosphere. We can make other kinds of automobile fuel from corn, wheat, soybeans, or sugarcane, or even water. These fuels do not put as much carbon dioxide into the atmosphere as gasoline does. It's important that we all figure out ways not to depend on fossil fuels, because this planet belongs to all of us. All of us need to take care of it. What ways can you think of to help? Here's a few facts about gasoline. Across the earth, about 83 million barrels of crude oil are produced a day, and about 83 million barrels of oil are consumed a day. There are 42 gallons of crude oil in a barrel. 1 barrel of oil can produce 19.6 gallons of gasoline. A little bit more than my car takes now. The United States consumes about 400 million gallons of gasoline a day. Wow. That equals 146 billion gallons of gasoline a year. That's more than any other country consumes. I know you'd be surprised to learn it, right? That the United States, we're not the most populous country on earth. And we feel like we're doing some steps to help the environment and to stop the consumption of these fossil fuels. But still, we are the biggest consumer of fossil fuels on Earth. All right. It's interesting about this story. The author certainly gives us a lot of information, but that information is meant for us to feel something. How did your opinion of gasoline change from this? How did the graphics and illustrations that they used help you to understand? I hope you all have a great Monday, and I'll see you very soon in office hours. Have a good one.